Dear students, good morning. I'm Dr. Zara Khan, and today's lecture is about Introduction to Damped Vibration in Single Degree of Freedom Systems. In last lecture, we discussed degree of freedom. If someone has question related to that, they can ask. In today's lecture, we will discuss concept of vibration in mechanical systems, concept of damped vibration in mechanical systems, and behavior of single degree of freedom system in damped vibration. So first of all, let's understand vibration. It is basically oscillatory motion of an object or a system. A system can be any mechanical component or an assembly. It occurs when a system is subjected to an external force or disturbance. For example, the fluttering of an aircraft wing. It happens because of the load of the fuselage, the load of the aircraft engines, and air drag. So it is very important to take it in consideration and devise a proper damping mechanism. Vibration can have harmful effect if not considered during design. For example, this car has a failed shock absorber, and this happened because of a prolonged vibration. So to control such kind of failures or fatigue failures, we have to devise a proper mechanism for damping of the vibration. Now, what is damping? It is basically a dissipative force that diminishes the vibration with time. For example, if we look at this figure, you will see we have two mass spring systems. One is undamped and the other is damped. If we look at the amplitude and time graph of these two mass spring systems, you will see that the amplitude of a damped system is decreasing with time and eventually diminishes. This is because of the damper. So there are three types of damping mechanisms. Number one is viscous damping. It occurs due to the presence of viscous fluid such as oil or air in the system. The dissipative force generated is directly proportional to the velocity of the system. So basically that is written over here. Hysteresis damping, basically hysteresis damping arises from the hysteretic behavior of material in contact with each other. For example, in crankshaft mechanism or crank slider mechanism. When the system undergoes cyclic loading, the energy dissipation occurs due to the internal friction at the contact forces, the surfaces, Structural damping. The dissipative force arises from internal friction. This internal friction may be the bending, compression, or stretching of the bulk, and basically it is dependent upon the material properties. So, going on to the equation of motion for damped vibration, this is a schematic of simple mass spring system with a damper. And using Newton's second law, which is summation of forces equals to mass times acceleration. We'll use that relation. Here the reaction force in a free body diagram, this is due to the spring, K is spring constant and X is the displacement. Here C is basically damping coefficient and X dot is velocity. So these two forces when added up will be equal to mass times acceleration of the body. So this is the equation derived from that, and here abbreviations. So moving on to the damping ratio. Damping ratio is basically ratio of actual damping coefficient to the critical damping. It is represented by the symbol which is called zeta. Now moving on to response of a damped system. There are three types of responses: underdamped, overdamped, and critical damped system. The system returns to equilibrium in the shortest possible time without oscillation in critical damped system, where the zeta is equal to 1. In overdamped system, the system returns to equilibrium without oscillation, but it will take more time as compared to critical damping. On the other hand, underdamped system, where zeta is less than 1, the system oscillates with gradually decreasing amplitude. These can also be seen from the graph. Now to conclude the lecture, damped vibration is an essential concept in the study of mechanical system. Understanding the behavior of single degree of freedom system in damped vibration is crucial for design and analysis. And last one is proper control of damping help mitigate harmful effect of vibration and ensures system stability. So these are the crux of the lecture. So that's it for today's lecture. Thank you so much. See you in the next class.